So in the next few videos, we're going to talk about this type called as reducible to exact differential equation. Now I'll tell you what exactly we are going to do here. First of all, we all know the standard form. Okay, the standard form for the exact differential equation is something like this. It is m dx plus n dy is equal to 0. Okay, now once you get the standard form, next we have a test. Okay, that dou m by dou y, that is partial derivative of m with respect to y, is equal to partial derivative of n with respect to x. Now this is the condition for exact. Okay, now what is going to happen in type 2 is, if this test fails, right, that if your dou m by dou y is not equal to dou n by dou x, then obviously it is not an exact equation, exact differential equation, right? And when we have a not exact differential equation, we have a few rules or few techniques by which we can actually convert a not exact differential equation into an exact differential equation. And precisely we will be studying 4 rules to do that, and hence we call the type is the reducible to exact. So we reduce the equation to an exact differential equation. So let me write down all the rules now. So now let's look at rule 1 and rule 2. These are the rules to convert a not exact differential equation into an exact differential equation. So it's very simple. What we do is we subtract dou n by dou x from dou m by dou y, and just observe that if we are subtracting dou n by dou y, then we divide that by n, and then the answer has to be function of x. Okay. Now if this happens, we will find something called as IF. And IF is integrating factor, and the formula for IF is e raised to integration of f of x dx. Okay, we will find IF like this, and with the integrating factor, we can already convert the non-exact differential equation into exact differential equation. That is how rule 1 works. Now rule 2 is quite similar, so we should discuss rule 2 as well. That in rule 2, we have just exchanged these two. Do you see that instead of dou m by dou y minus dou n by dou x, I have done the other way around, dou n by dou x minus dou m by dou y. And then I divide by m also. Notice that we have divided by n over here, and here we divide by m. So what we subtract, okay, just remember like that, that value will write in the denominator. And once we do this, we solve this bracket, the answer has to be f of y. And as soon as you get that as a purely a function of y, then we write down integrating factor as e raised to integration of f of y dy. And again, this integrating factor can easily convert our non-exact equation into an exact equation. So this is how rule 1 and rule 2 works. Now we have 2 more rules, but rule 3 and rule 4 is slightly different, and it directly gives you integrating function. Let me explain what I mean. Now the rule 3 says, if you have a format which is f of xy times y, we can just call this as f1 one function, and say f of f2 xy x dy. If this is the format, you will understand this better when we solve a problem. Now if this form comes, okay, then we can directly write down integrating factor like this, which is 1 upon m multiplied by x minus n multiplied by y. Okay, and here we get directly the integrating factor. Now next is going to be rule 4. Now in rule 4, if we have a homogeneous differential equation, what I mean by that is, if you have power of each and every term, okay, the sum of power of each and every term is same, we call it a homogeneous differential equation. And in that case, we can find integrating factor directly. It is like this. The formula is 1 upon mx plus ny. Okay, so I hope you can observe that in all the 4 rules, we are finding something called as integrating factor. Now, as soon as you find integrating factor, the next step is going to be that we will multiply m with integrating factor if, okay, which can be any rule that you're applying, rule 1, 2, 3, or 4. You will simply multiply your m with if, and the resulting answer is going to be m dash. And similarly, you'll find n dash as well, which is n into if. And if is really like a magic factor, okay? So when you multiply by if, and when you get dash m dash and n dash from m and n, and if you write down m dash dx plus n dash dy equal to 0, now this form here is 100% exact. So this is definitely going to be an exact equation. So what we have achieved with the integrating factor with the four rules here, that we have converted a non-exact differential equation into an exact differential equation. Okay, all these rules, how they actually work for a problem, you will come to know when we solve some of the question. And in the further videos, we're going to solve one problem for each and every rule, so that you understand things better.